Welcome to our Azure Incident Retrospective. I'm David Steele.
I'm Sami Kuba. We work in the Azure Communications team.
In addition to providing a written post-incident review after major outages, we also now host these retrospective conversations.
You're about to watch a recording of a live stream where we invited impacted customers through Azure Service Health to join our panel of experts in a live Q&A.
We had a conversation about reliability as a shared responsibility. So this includes our learnings at Microsoft, as well as guidance for customers and partners to be more resilient.
We hope you enjoy the conversation that follows.
Super. Today's incident we're going to focus on is around Azure OpenAI. It was an incident in Sweden Central where customers experienced errors and failed inference requests. This happened twice, once on the 27th of January and once on the 29th of January. There was an unrelated issue on the 28th where there was only latency, but we're going to be focusing on the 27th and the 29th for now. One of the major contributing factors to this was Microsoft 365 Copilot and its use of Azure OpenAI in this incident. So we're going to talk about how requests bypassed our cache. They hit a metadata table and a metadata service, which caused a cache stampede, which is the first time I've heard about this, but excited to learn more.
We're going to have to figure out all those different pieces. And so to help us with that, I'd love to introduce a couple of engineering leaders joining us on our panel today. On my right-hand side, first up, we have Hemant Kumar. Hemant is our Partner Group Engineering Manager from the Azure OpenAI Service. Thank you for joining us. And we've also got Sindhura Bandakavi. Thank you, Sindhura. Sindhura is our Director of Engineering from Microsoft Foundry, one of the key players here. Thank you both for joining us.
Thank you for having us.
Thank you. Hemant, can I perhaps start with you? Could you give us a quick introduction into Azure OpenAI? And I know we were talking about Sweden Central in this, but there is this global and regional construct within Azure and OpenAI. And some people pick a global thing and it gets distributed somewhere into the cloud. Some people are Sweden-specific or region-specific. Could you talk us a little bit about how Azure OpenAI manages regions?
Sure. Let me start with what Azure OpenAI Service is. So Azure OpenAI Service is our inference service, which provides inference as a SaaS service to our customers. It provides access to Azure OpenAI Service provides access to OpenAI models, but the service is broader than that. In context of Foundry, we have many other models, Grok, Mistral, Anthropic, and many others. So all of them are can be consumed in a SaaS as a SaaS service by our customers. Now, as you pointed out, we have many different offers for these the SaaS service. Some are regional, which are meant to address regional data residency requirements, and some actually allow for much bigger scale as capacity becomes available across regions, and customers can get much more quota in the global footprint. So for those, the data always stays within the region where you provision the Azure OpenAI resource. It's the inference requests which can be serviced by any region in the world. In the middle of the two, we have data zones, which provide a slightly bigger perimeter. So we have Europe and US as data zones. And customers can use it to get higher quotas and throughput if their use case allows them to go get inference requests serviced in that broader region.
Cool. That's great to understand. So we've got those different options for customers depending on their requirements and where they need that to land. Okay, that's right. A good starting point. Sindhura, I'd love to bring you in here. So what are the elements of the architecture of Azure OpenAI that we need to understand? Before we talk about the incident itself, like that we were talking about, there's a data store, there's a cache. Can you just kind of paint with your words for us to understand the different characters of the story?
Absolutely. As you know, Azure OpenAI Service is an Azure service. And as any Azure service, we have control plane operations and data plane operations. Control plane operations are you're creating your account, you're deploying a model to either a region or globally. Those are control plane operations. And data plane operations are when you're using the service. You're calling Azure OpenAI chat completions or responses. You're using that service, the inferencing in your application. Those calls are all the data plane operation calls, right? So now in our architecture, when you perform control plane operations, it generates control plane metadata. Right? What accounts are available to the subscription? What are the deployments that are there in the subscription? Those account metadata are stored in control plane metadata database, which we use Cosmos DB for. And there is a metadata service on top of it that provides this information. This is internal service that provides that information to any of the upstream services that are providing the data plane operations, right? So we for the control plane operations and the control plane metadata, we have this metadata service, and then we have our highly scalable Azure OpenAI Service data plane that uses Azure API Manager and Redis Cache for supporting our data plane operations.
That's right. I just want to add to what Sindhura said about how we build the data plane. We build this data plane, it's a massive service. It's used by all of our Microsoft internal customers, like M365 to serve Copilot requests, for GitHub Copilot to serve any completions that you see in GitHub. So this service is used by both our external customers as well as our massive internal customers. And the scaling story, as well as the concept of isolating failures, is how we work to expand the service as we are building scale. So we have failure domains, where individual customers are provisioned. And there are multiple failure domains in Sweden Central, as it happens to be one of our larger regions. In this case, one of the things that I want to point out is that the failure domains didn't hold the failures. So it spread from one to the other, and we'll go into some of that detail.
That's really interesting. It's cool to hear about how we use our own ingredients. We use Cosmos and API Manager and Redis Cache, like as we're building Azure. I find it really cool that customers and our own services use the same thing. If we fast forward to the incident, we spoke about the inference, we spoke about how the control plane and the data plane are built. As a user, as a customer, what was my experience on the 27th and the 29th? What did my failures, what did my errors, how did that come across?
Yeah, on 127th, there was a huge amount of availability impact to all customers using Sweden Central, both our internal customers as well as our external customers, Azure customers. And in addition to that, there was latency impact, which was substantial to our customers. So the requests, which used to take hundreds of milliseconds, went up to many seconds, and customers may have seen timeouts on those requests.
I wanted to add, so there is, if your application is directly using the APIs, of course, your application is going to see latencies and errors. But also, if you were using Microsoft Foundry Portal, using the playgrounds in a project that's in Sweden Central, or you were using agents that are using models that are in Sweden Central region, you could also have seen latencies, spinning circles, or errors as well. It was not. The SLA impact was actually not all customers, so it was a percentage of customers, right?
It was a substantial amount. I think the availability was down for about, at its lowest, what we saw was about 40% was the availability in the region. Yeah. In addition to that, the latencies were orders of magnitude larger.
And if customers were retrying and trying again, was it Correct. Some success or no?
No, there was some success, okay. But because of how the systems worked intermittently, okay. There was some success. It was intermittent success.
Okay.
Okay. It sounds painful, but I'm glad that we could understand, both the magnitude of it, and for any individual customer, sometimes retries helped, sometimes not so much. So thank you for explaining the different kind of pieces of the story there. So, Sindhura, I'd love to talk about the trigger event for this issue. We try not to talk about root causes. There are lots of contributing factors, but at least chronologically, we know that one of the big things that happened here was the sudden increase in traffic, right? I know in the post-incident review we talked about the surge, and we identified that actually came from one internal tenant, Microsoft 365 Copilot, since that runs, in part in Sweden Central. That was this big customer that came out. Now, can you talk to us a little bit about the cache rejecting that request? Because that's what I would love customers to understand here. When I try to picture a cache, I just naively assume that, if the cache would reject one request and then keep serving other people's requests, but that's not what happens in practice.
Yeah, so it's super interesting. It's a lot more complex than that, as we have realized through our investigations. Maybe is it okay if I share the story of how we discovered it and then what we identified? Or?
Sure, great.
Okay, so the incident triggered when as we saw the live site availability reduce, and we had the live site incident get triggered. And so what we noticed was that this metadata service was not returning the responses as it should, right? So, and At that time, we didn't know it was surge in traffic.
Okay.
At that time, what we saw was that service is not able to respond to requests. And so the immediate investigations we had for mitigation was look into that service. What's the health of the pods looking like, and how do we scale it up? So some of the mitigations we did was restarting the pods immediately, checking were there any deployments recently that could have caused it, and undoing those deployments, while at the same time we were investigating what exactly is going on with the health of the pods, right? So what we noticed was that the memory consumption was really huge, and when we were we saw the Kubernetes killing the pods as we were trying to scale out the nodes, right? So the symptom we saw was that the service was crashing because it was hitting its memory usage, and our attempts to scale out the nodes were failing because the kubectl was just killing those pods as they were coming up. That is what we noticed.
Right.
And then later, we found that the reason for that was a whole bunch of issues that we discovered later. And the trigger was this traffic.
I want to add to that. This has been this is a multi-system failure where we had 4 systems interacting at a scale which had recently been reached, and the coupling between those systems unraveled. The trigger point was increased traffic. It was not a surge. It just hit a peak, which was bigger than before, not substantially by several percentage points, but we went into the red zone. And the coupling of the system is what triggered the cascading failure. Like many cascading failures, it's very hard to separate out the cause from the effect. So what Sindhura is pointing out is we saw the huge memory increase. It was the effect, not the cause. The cause was the increased traffic, the number of requests, and the cascade of requests that kept happening because the metadata service couldn't respond at the rate the data plane was hitting it, and it was not designed for that.
Yeah, I was thinking about this last night, and one of the analogies that came to my mind was, think of a restaurant that serves buffet. It is highly scalable in the sense lots of customers can come and serve themselves, and the restaurant can scale. Now imagine if someone came and removed a dessert tray saying this dessert is not good, and then all the patrons are rushing to the kitchen to get their own piece of dessert. The kitchen staff and the chef probably crash and then just shut the kitchen down. And that's kind of what happened in this case, which is the metadata service. The kitchen didn't fail. It was not designed for serving all of those customers at once. So in this case, the metadata service was supposed to serve the data plane and the cache, and was supposed to protect it. And when all of these customer requests came into metadata service, it just crashed because it was not designed for it.
That's our cache stampede. When we were talking about cascading failures and the complexity, I find it really interesting to say, over time we hit a limit, and then the limit tipped us up, and then things started failing in multiple places. During an outage, during an incident, how do you investigate that? And how do you go about mitigating when you don't know exactly what the cause is? And how do you protect the system? Because we need to get the service back up and running, but we're seeing failures in multiple domains that are all connected by some bizarre thread. How do you go about investigating and mitigating things like that?
Were either of you on call during this?
I think both of us were. And Sindhura was the primary incident manager for the call as well. Talking about this specific case, the first response was what we were observing, which is the metadata service crashing. So we scaled that out. We observed, but the impact on customers really came from data plane failures. And so what we were focused on was mitigating that impact. The reason that impact occurred is because we didn't have the crucial piece of metadata that each request needs in the data plane, in the Redis cache. So as part of this, the next step was to extend the time to live for this so it becomes available And that is actually, that was done during the 27th outage. And that coupled with reduced traffic actually led to service recovery. It also helped us on the incident on 29th, which was much, much less severe for customers. In terms of availability, the impact was in high 90s, like the availability was in high 90s, so there was not huge amount of degradation. The latency was barely impacted. And so it impacted customers and request sources which were not previously present and therefore could not have been cached. But our caches actually saved us that day. And this was part of the mitigation that we had enabled on 127.
When we increase our time to TTL, our time to live, do we say we're going to accept latency as long as we conserve it? Is that what we're doing? We're increasing the window? Am I thinking about it the right way?
I think what we're doing is we're saying consistency can take a slight backseat to availability. Okay. So the trade-off we're making is we are biasing for availability and saying, even if this is not the freshest data, we will continue operating on it. This metadata changes ever so slightly, and therefore, and there was work done in very recent past to actually have to be able to have much more increased time on this. So we leveraged that capability that we were working on in December and early January. Okay. That came in very handy right in the nick of time.
Yeah, I'd love to understand, because you've touched on kind of, especially on the 27th, and how we started to investigate and understand that. When it came up again on the 29th, were we better prepared because of the mitigations we'd put in place, or we knew what to look for and therefore we were able to react to it differently?
Yeah, we were definitely better prepared, and that was mainly because of those two mitigations. One, the metadata service was scaled out, and the memory was also scaled up, right? So that those two things saved us a lot, so that we were better prepared. The second thing, we were better prepared with the people aspect. Everyone in our organization knew about the incident, and everyone was prepared to help us around. Mm-hmm. So then the third thing I wish could have been different was our outage declaration was not automated. So on the 27th, there was one more thing that we did, which we knew that our outage, all of this was detected automatically, but it was the extent of the impact was not automatic to the brain system that we were using. So it did not automatically say this is an outage that would trigger all the incident responses and escalations that should have happened automatically, right? So we missed that piece on the 27th. So we knew that we need to do something different. And we added extra monitoring on the metadata service, but on memory. And the next day, the memory consumption was fine because we scaled it up, but the CPU consumption got hit, and the service crashed again. So if I could have, I know that there was a lot of things that went well, but if there was one thing that could have gone better is if we could have detected it even sooner than what we did, even on the 29th.
I want to add to some of the complexity of the system. I think that's worth going into, because this system, this failure was kind of one of the more involved failure modes. So in this case, really what we found was there was three factors that contributed to it. One was the large account metadata that M365 deployments had. They had a large number of deployments underneath a single account creating a large metadata. The second aspect was the request rate was large. And then the third aspect that came into play was this account metadata was getting invalidated because of bug in the control plane. So it would come to Redis, stay for 3 seconds, get invalidated. And we would go fetch it from the metadata service, we'll cache it. But then to serve it, it needs to be pulled into the gateway nodes, which have their own node memory. So they would, as requests came streaming in, they would all try to pull this Redis state from Redis, which actually overloaded Redis outbound basically bandwidth. And so some of these calls failed, which in turn hit the metadata service, which fetched this new data again, account metadata again, populated in Redis, as a result, invalidating the local caches, which again went to push-in. So it kept like building up.
That's incredible.
And David, this is the answer to your question you asked earlier. Why was Redis not rejecting that one request? That's not what happened here. Redis got overloaded and the bandwidth got hit, and then that's why it was not available.
Right, that makes sense.
When we think about the learnings and repairs for this, one of the things we said is we've scaled up the metadata service, and it's robust. But you mentioned earlier to say we don't know we're going to hit a threshold until we hit it, and then it falls over. Have we scaled out now? This should last us a year, 2 years. At what point in time do we say our metadata service needs to be scaled out and up again? How are we thinking about the robustness of that service?
I think it's a design point.
Okay.
Metadata service is not meant to serve data plane scale. The ideal way is to actually decouple the availability from this metadata service. And so what we're working on and what we've done to a large degree is, like I mentioned, there are 3 contributing factors here. One is the account size. We can be much more targeted in what we are getting from the metadata service and storing and consuming in data plane. It is a very small subset of that data. The second aspect is the amount of invalidations. We can be much more targeted when we do those invalidations. And second, third aspect is it operated at request speed. So the larger the number of customer requests, the more the number of requests to Redis and to this metadata service. What we have implemented since is stampede prediction, which is basically when you're seeking one specific state, you're not sending all requests from the node. There's a single request going to both Redis as well as to this metadata service. And then all the completions are behind that one request. At any given point in time, there would be no more than one request. And so we are trying to decouple the request rate from the cache rate and from the metadata service rate.
Cool. That's interesting to understand. I'm trying to parse that against some of the repair items that we mentioned in the post-incident review. I think we mentioned, one of them, for example, was we're going to have better monitoring around memory usage. But to your point, Sindhura, sometimes it's memory, sometimes it's CPU. So how are we thinking about investigating this resource exhaustion issues in its entirety? Are there more that we can do around kind of keeping an eye on that and being more responsive?
Go ahead.
Absolutely, we do. We are actually systematically doing, again, the prevention is better than cure, right? So we are looking at our entire architecture, finding SPARFs, where are our single points of failure, how do we set the resource exhaustion limits, as well as auto-scaling for resource exhaustion limits, but also identifying and detecting early that, hey, this resource is reaching the limits, do something about it, because you would have a longer time lead to do something about it.
Specifically on detection, I think one of the pieces that Sindhura pointed to was really about our AIOps detections, right, which are plugged into the availability SLI. Yeah. And they fire if they determine impact automatically within minutes. And so that system didn't work, as Sindhura pointed out. Part of the reason was there's a dependency of that system currently on the very metadata store that wasn't serving at the time. So what that meant was we had the indication of which customers were impacted. We could not map that to subscriptions of the customers because that information comes from the metadata store. Mm-hmm. And as a result, our AIOps system didn't serve us well. And we didn't. So it pointed to a weakness in our detection logic itself. And so that is the part that we're working to decouple also from detection. Ideally, what we want to do is we don't want to put targeted detections. We want to put detections on customer experience early on. Targeted detections tell us which systems are behaving in a suboptimal way and help us mitigate the issue. But the first step is really detecting the issue as it happens and having broader coverage of issues that our customers are seeing.
So, is there anything our customers could have done when something like this happens? Should they Can they fail out to other endpoints? If they've picked a globally thing, do we put them somewhere else? Is there anything customers can do? Or in an outage like this, do they just have to endure it? What options do customers have?
Yeah, I think, so Azure OpenAI Service is available in more than 30 regions. And in this case, it was a regional outage. So customers can definitely use other regions. It is challenging for a subset of customers which are specifically using provision throughput, for example, because that's a provisioned offer in a specific region that they're using. For pay-go or consumption-based customers, as long as they have quota, they can move to a different region to get served. It would be a different account. It would be a different gateway which is going to be serving it. In our approach, what we're trying to do is just build better failure domains so we can contain the impact to our customers.
That's really good to understand that, look, hey, there's some complexity involved, but if possible, if this is something mission critical for your organization, you can architect with endpoints in multiple regions. You can handle some of that so that your ship is big enough that there's no one region having an issue that can stop it from going down. So for some customers, that'll be worth the trade-off, and for other customers, they'll wait for us to bring it back online. So that's great to understand kind of customer learnings as well as the learnings on our side. So Sammy, I wondered if we should touch on customer communications here. I know Sammy runs our incident communications team. Were we able to keep customers updated during these two issues?
I mean, yes, it was incredibly late. We rely heavily on that automated brain system. The SLIs that come into AI Ops sends not only detects which customers are impacted, but communicates to them. And so we have this auto communications thing, which is great to put out a flag immediately to say, it's an us problem, not a you problem. And so we don't have customers retrying and getting frustrated. And that didn't work today for the reasons that Sindhura and Hemant covered. In lieu of that, completely separate, we had an issue with our communications tool. And so in lieu of understanding which customers were impacted, our choice was to tell everybody in Sweden Central, we're having a problem, it's an us problem, not a you problem. And then later on, we can go and correct and say, actually, it turns out you weren't impacted, you were. We would work with the engineering teams to find out who was and wasn't impacted. Because our tooling was impacted, the only thing we could have done was to go public on our status page, which we really don't like to do unless there's a huge outage. But given that we didn't have a way to send targeted comms to Azure Service Health, we started initially broadly on our public page. Later on, as time gone on, we got our tooling repaired. We had another incident where we got that mitigated. Our tooling repaired, we sent customers communications. Similarly, when the 29th occurred, we were in a little bit of a better position. Our tooling did work. We sent targeted communications to impacted customers. Typically, it's hard to determine who is or isn't impacted, and we over-communicated. And then afterwards, we told customers, that they were or weren't impacted. We managed to get communications out within a couple of hours for the first one. On the portal, one of the things that I noticed as I'm going through the communications is when we have people who want to tell customers what's going on, and we have engineers, and everyone's on the bridge working together. And one of the things that I saw is we told customers, you should fail out of the region. And it's really interesting because we shouldn't tell customers to fail out of the region. And someone in the engineering team might say, this is a great idea. And it might be for some customers, but really the position we want to have is to say, this is going to take 1 hour, 1 day, 5 hours, 5 days a week. And customers can make their own assessment. Some customers can endure 1 hour, some 1 day, some 1 week. And so to say fail out the region, some customers might infer, well, the region's imploded. Clearly, you can't recover Sweden Central, which isn't the case. And so we need to do a better job of saying, here is the details that we know. Now you know everything we know. It's going to take us 3 hours. This is what we're doing. You can make the assessment on whether you want to fail out or so on. But we have learnings in the comm space because of that.
Yeah, that's a really important distinction, because for some customers, that's a great option, and for other customers, depending on the scenario, that's not helpful to them at all.
Absolutely.
Okay, so we could have some learnings from comms as well. I mean, thank you for joining us today. Thank you, both of you, for running us through it and explaining some of the different elements. I especially like when we can be transparent about, well, it's not as simple as that. There's a trade-off there. So thank you for running us through it. Thank you for watching this Azure Incident Retrospective.
At the scale of which our cloud operates at, incidents are inevitable.
Just as Microsoft is always learning and improving, we hope our customers and partners can learn from these too, and provide a lot of reliability guidance through the Azure well-architected framework.
To ensure that you get posted incident reviews after an outage and invites to join these live stream Q&A sessions, please ensure that you have Azure Service Health Alerts set up.
We really focused on being as transparent as possible and showing up and being accountable after these major incidents.
Whether it's an outage, a security, or a privacy event, Microsoft is investing heavily in these events to ensure that we earn, maintain, and at times rebuild your trust. Thanks for joining us.